Welcome back, everybody. In this video, we're going to start looking at applications of percentages. And I'm going to do a few different videos on applications of percents. There are really so many applications that I can't do every single one, but I'm going to do a lot of them. In this first video, it's going to just be kind of general applications. So just kind of some, not totally random, but just kind of some mixed problems and mixed applications. And then we'll focus in other videos as well as a little bit more specific applications too. So this one will be a little bit more general. All right, so in this particular video, I'm going to look at general applications of percent and then also percent increase and decrease, which is, again, like a general application of percent here. Okay. The total mileage of the Appalachian Trail is about 2,174. The number of miles of the trail that go through New York. Sorry, I should say the percent, sorry, not the number, the percent of miles of the trail that go through New York is 4%. How many miles go through New York? Round to the nearest whole mile. And the source here is purebound.com. All right, this is another little tip here. So I think most of us are probably from Massachusetts, or maybe not originally, but now, but not everybody. So 4% is also the percent for the mileage in Massachusetts as well. This is a fun little tip. So we're focused on New York, but Mass would actually be the same. So the total mileage of the Appalachian Trail is 2,174. The percent of miles of the trail that go through New York is 4%. And our question is, how many miles go through New York round to the nearest whole mile here? So let's see what's going on. So I know, I'm just going to underline some key things. The total mileage of the trail is 2,174. I also know that 4% is the amount that goes through New York. And my question here is to find out how many miles go through New York, right? So this right here is my goal. Find the number of miles in New York. Now, I am going to use that kind of general form we talked about before. And this was in our last video. Let me see if I can find it in my notes really quick, about the percent equation. So it sort of has this basic form of percent times base equals amount. And I kind of mentioned a little bit what the base represents and what the amount represents. So I'm going to rewrite this here in our lecture notes because this idea is really going to help us with the application problems. Because in a lot of application problems, the words is and of may not be very clear. So let's rewrite that equation here. Now, the base and the amount can mean different things, but I'm going to give you the ones that it most typically means. So for your base, you're typically thinking of the whole, the total, the original, the starting value, so something like that. And the amount typically represents the part or the portion you're looking for. Okay, so the problem is based on. And again, those terms don't work 100% of the time, but they do for most of it. So I think it's worth kind of pointing that out here. All right, so let's try to set this up then. So I know my goal is to find the number of miles in New York. And I'm trying to fill in the other pieces. Now, hopefully one of the pieces should be easy to fill in here. So I do see my percent is 4%, and make sure it's the correct percent that you're looking at, right? So if you think about your question is about New York, and my percent is also about New York. So you do want to make sure the data lines up. This makes sense. So 4% is our percent. So my percent here is going to be 4%. Now, your base is typically representative of the whole or the total. So in this particular example, the whole would be the entire Appalachian Trail, right? So this is my whole. And it's kind of tricky because you have the word is here, right? So you may be thinking like, well, no, is means equals, that should be on the other side. But with application problems, with word problems, sometimes the word is just the word is, right? It's an English word. We have to use it sometimes. So it doesn't actually represent equals in this case. So we're looking at the total here, and our total is 2,174. Now, the amount is usually the part or the portion that you're looking for. So here we're not looking for the entire trail, we're looking just for New York. So I want to figure out the miles in New York. That's going to be my X in this case, right? This is my variable. So this is going to be what I'm trying to find for this particular problem. So this is our part or our portion. Couple things you do want to check. One is that your units should match. So I do want to note that these have the same units. So my base and my amount are both miles. So you do want to make sure your units are consistent. And then again, your percent should relate to your amount. And then the other thing you're looking for is that the percent and amount are related. And in this case, again, they both represent New York. So that's just a couple little quick checks to make sure you're on the right track. Not a perfect check. Word problems, I never have a perfect check for you, but at least we know, okay, my base and my amount should have the same units, and my percent and my amount should be related. They should be the same idea. So they're both based on New York here. So this is going to be our formula. So I'm going to change this over 2 spots to the left. So I'm using 0.04 times 2,174 equals X. And you can definitely go ahead and use your calculator here. So I'm just going to save us a little bit of time. And what you get is 86.96. Now the problem just asks us to round to the nearest whole. So the nearest whole is the ones position. So that 9 is going to bump that 6 up. So you're going to get 87. So there are about, and remember what was my question, right? My goal was to find the number of miles in New York. So that's what my X represents. So there are about 87 miles of trail in New York. In this video, I'm just going to do a whole bunch of different examples. So let's do another one. A school recently had 20,000 applications. only 2,500 students were accepted. What percent of the students who applied were actually accepted? So I think everybody who's here knows that their colleges have different levels of competitiveness to them, right? So some schools may receive thousands and thousands of applications and they accept very few. Other schools may receive applications and maybe they accept most students, right? It really just depends on the school, how many seats are available, and how competitive those seats are. So I'm just making up this example, by the way, it's not a real school. But let's say that one school received about 20,000 applications for its next incoming class, and they accepted 2,500 students. Okay? So those are the students who necessarily attend, but those are the ones who have the option to attend. So our question here is, what percent of the students who applied were accepted? So this is our goal, to find the percent, so the percent of students accepted. So that's going to be our X. So I'm going to set this up. So percent times the base equals the amount. Now, I don't know the percent here, that's my goal, so I'm just going to fill that part in right away. So that's going to be the X. Now, your base, remember, is usually a total or a whole amount, and the word amount usually represents a part or a portion. So if I go back through my data, I do see I have two main values, right? So I have the 20,000 applications. So these are the total applications submitted. And then I have the 2,500. This is the part who were accepted. So if I think about what I have here, my base must be that 20,000, because that's the total. And the amount is typically the part that we're looking for, and that is the 2,500. So this is what my formula is going to look like. Typically, we like the number first, so I'm just going to rewrite this. It'll be easier for me personally to work with. And now I'm going to go ahead and solve. I'm using my calculator here. And I have 0.125, so 125 thousandths. Now, remember from the last video that when solving for a percent, we must change to the percent form at the end by multiplying by 100. So when you're solving an equation, we always work with percents in either the decimal or fraction form. So whatever your answer is at the end, again, only when you're solving for the percent, you have to multiply that by 100. And the shortcut for multiplying by 100 is to move the decimal point 2 spots to the right. So the answer is going to be 12.5%. So 12.5% of students were accepted. So not a huge amount. I mean, still a decent chance to get in, right? But not a huge amount. That's a pretty competitive school if they're only accepting about 12.5% of the students who applied. All right, you know what? I think I'm gonna get a nice clean page just so I have some room. Let's start over. All right. So in Professor Pollard's class on Monday, 6 students were absent. This represents about 30% of her total class. How many total students does Professor Pollard have in her class? All right, so Professor Pollard's class on Monday, there were 6 students absent. This represented 30% of our total class. 30% is kind of a lot. It's not half, but it's almost there. How many total students does Professor Pollard have in her class? So here is our question, right? So the goal here is to find the total students in class. So this is what my X is going to be. Notice here I see this word total. So your total represents your base. We must be looking for the base this time. And I do have my percent. That's always the easy one to find. And then notice that 6 students were absent. So this is the part were absent. So this is going to represent our amount. So my percent here is 30. I don't know the base, so the total, and the amount is 6. So think about this as a quick check. The 30% does relate to the 6, right? Because that's all about being absent in this case. So the percent and the part are both about being absent. And then if I think about my total, which is my total students in class here, and the part who are absent, they're both about students. So my units match there as well. I'm going to change this over. So 2 spots to the left. So 0.3 or 0.30. And then I'm going to go ahead and solve. And my answer is actually exactly 20 here. So we were looking for our total in this case. So Professor Pollard must have 20 students. So notice that we've actually done an example of each style. So in our first example, we had one where we were solving for the part. Let me scroll up here. We were solving for the part or the amount. In the second example, we were solving for the percent. And the example we just did now, we were solving for the base or the total. So we've done one of each style here where you could have any of those 3 pieces being the missing part. And you really want to think about those key ideas. So the words of and is are here. They can be helpful. So this one we actually, do see that word of. And it does say of her total class. So again, that word of is usually associated with the base. So we do also confirm here that the base must be the total class. So you have that idea being repeated, but the words of and is are a little bit harder to use in a real world problem just because of the wording, right? It's hard to read sometimes. All right, let's do another example and start getting into increase and decrease problems. These can be a little bit trickier. So obviously an increase problem is when from one value to the next, your answer is increasing. So what's happening in an increase problem is that your final amount overall is going to be bigger than your base. There's a couple of different ways to solve these increase problems, so I'll wait to do some examples, but overall you're kind of having the fact that from the starting point to the next point, you're growing. Whereas with a decrease, obviously you're decreasing, right? So you're going from a larger amount to a smaller amount. So let's look at an example first, and then we'll kind of go through some formal setup there. So in 2015 to 2016, the number of licensed drivers on the road in the US increased by 5.8, percent. In 2015, there were about 210 million drivers on the road. And then my source here, just as a side note, is the Federal Highway Administration. So part A, first thing we're going to do is we're going to find the increase in licensed drivers from 2015 to 2016. So what we're looking for in part A is not the total amount in 2016, it's the amount of the increase. So you want to be really careful here. There's a couple of different ways that you can think about increase and decrease. You can think specifically about the amount of the increase or decrease, so just how much is that value changing. And then you can also think about the final overall answer. So there's sort of like a two-part thing going on when we have increase and decrease problems. So if we're looking for the increase, then we're just looking for, this is the part for the amount that we're looking for. We're just looking for how much it's increasing by. I know it's 5.8%, but I want to know like how many drivers, okay? And I do know that my percent is 5.8, so that's pretty easy to find. And I do have this other information of 210 million drivers, and that was in 2015. So here it is a total or a whole, but more importantly, it is a starting point or an original value. So with increase or decrease, more so than totals and wholes, you're thinking about what is your starting point. That's really important. So 2015 comes before 2016. So we're starting in 2015 and we're going to 2016. So here I'm using the idea of percent times base is equal to the amount. Okay, so this is your starting point or the original. And this is the amount, in this case, of increase or decrease if we do a different problem. Okay, so it's the amount of increase or decrease, which is really the amount of change. Okay, so it's not the total answer. It's just the change from 15 to 16. All right, I'm running out of room. I should have used a new page. Let me just come up here. All right, so my percent we said was 5.8. Now, my base is my starting point for increase and decrease problems. So in 2015, I'm starting at 210 million drivers. So I'm going to just use the 210 and remember that my units are millions. And that's going to equal the amount. Now, I don't know the amount, right? That's what we're trying to find here. That is our goal. Right? So find the increase. So our goal here is to find the amount of increase. So that's going to be our x. So we're looking for the amount of increase. So my x is right here. And now I'm going to go ahead and solve. So I do need to convert this over first of all. 0.058 times 210. And again, just remember that that's going to be in millions. So I'm just kind of making it a little bit easier here. And I get that X is equal to 12.18. So my answer is that the increase in drivers, I should say licensed drivers, was 12.18 million, right? So just remember, I'm in millions here, not just 12 people. So if you wanted to see this number out, you would actually just multiply it by 1 million. So that's how you can change over. And then my second question is going to be, find the number of licensed drivers in 2016 who are on the road. So for this case here, the number of drivers in 2016 would be the same as the number of drivers in 2015 plus the increased amount, right? So, and again, it's going to be plus because we're increasing, we're trying to make it more. So the number of drivers, and don't forget that this little hashtag also means number. Before it was a hashtag, it meant number, or the pound symbol. So number of drivers in 2015, we know that it was 210 million. We're increasing it by 12.18. So altogether, this is 222.18 million. So in 2016, there are 222.18 million licensed drivers on the road. Now, we can see with increase or decrease problems, it does get harder, right? Because it's like a two-step idea here. You first have to think about the change, and then if you're increasing, you're going to add that to the original value, or if you're decreasing, you would subtract it with the original value, right? Because we're decreasing, we're going down. So that's sort of one way to think about it, is to think about it in two separate parts. There's also a way that you can think about it all together in kind of one big equation, but I think I'm going to start with the two separate parts first. And let's try that out. All right, so let's just kind of talk a little bit more about like definitions and general formulas here. So let's do actually, you know what? Let me hold off on this. Scratch that. I'm going to come back to that page in 1 second. Let me just summarize for a second what we just did. So the first thing we did in the last example, oops, we found the change or the amount of increase or decrease. So for instance, we started with that formula, percent times our base is equal the amount. And specifically for this style problem, your base is really your original or your starting amount. And then the amount here actually represents the amount of increase or decrease, or you can think of it as the amount of change. And then the second thing we did there, we took the, see if it was an increase, we took the original value, we added the amount to get the new value. Or if it's a decrease, we would take the original value, subtract the amount to get the new value. Okay. So we sort of had a two-step process here, and I do want to clarify that for this example, in this style, what we were trying to do is we knew the base and percent, and we needed to find the amount. Okay, so it is important. There's a couple of different ways to do percent increase and decrease problems. Sorry, my camera just froze. There it goes. And it depends on what you know. So for this particular example we just did it last time, and this is a pretty common style to do, is we knew the base and we knew the percent. So we knew the original value and we knew the percent, and we needed to find the amount. So when that's the case, this is how you're going to set up those style problems. So we're able to find the amount pretty easily by multiplying the percent in the base. And that's what we did in that last example here. And then we were able to, in this case, add, because it's an increase problem, add it to the original value or the original starting value there. If it was a decrease problem, we would subtract it. So we do see that a lot, particularly if we're doing like a percent decrease if an item is on sale, for instance. I'm going to hold off on an example there because we're going to do one on discount in the next video. So in the next video, we're kind of going to focus on money examples. So this is how we do that setup here. Now, this setup does not quite work if you don't know the base. So if you're working backwards, it's a not much more, but it is a more complicated problem if you know the amount and you know the percent. So as long as you know that change amount, then you can still solve this, and you could solve for the base instead and kind of work backwards. But you do need to know how it changes, and sometimes it's a little bit hard to figure out. So this particular example we knew the base, we knew the percent, and we were able to set it up pretty straightforward. Now, in the next example I'm going to do, and this is kind of why I wanted to pause for a second before I jumped in, we're going to talk about percent of increase or decrease. So here we know the base and amount, and we're trying to find the percent of change, whether that's increase or decrease. So again, this is a different style than the last example we just did. All right, so for percent of increase, what you do is the following. You take the amount of increase, so that would be like the part there, and you divide it by the original amount or the starting point. And then you write the quotient as a percent, right? So remember, multiply by 100. If you're trying to find the percent of decrease, it's going to be the same thing. You look at the amount of decrease and you divide it by the original amount. Then write the quotient as a percent. Now, again, this is just one way to do it. You actually can still use that original formula that we have been using this whole time, that percent times base equals amount. It just kind of simplifies the process here. So let me show you that in green for a second. So percent times base equals amount. So what we did above here, notice that your percent is already solved for. guys. All right, so notice that your percent is already solved for in that formula. So what they did was they just took that original, okay. They took that original formula here, and then they just solved it for percent. So what they did is they divided both sides by the base, because remember, base is your original amount. So it's actually the same formula. It's just set up where it's already pre-solved for you, just making it a little bit easier and kind of saving you that work. But it is the same formula. So if you forget, you can always go back to the original one that we know and just use that too. All right, so let's try out 2 more examples here. The number of applications for a job increased from 34 to 45 in 1 week. What is the percent of increase? And we're going to round to the nearest whole. Whole percent. So we're talking about an increase problem here. And the question is, what is the percent of increase, right? So we're finding the percent specifically. So what we can do instead of going back to the original problem is we can save a little bit of time and just use this formula here. So you're looking for the amount of increase over the original amount. So amount of increase is the amount of change. Okay, and same thing for decrease. That is how much it has changed. So how you can find the amount of change is to compare the original and the new values. So sometimes they'll give you the amount of change in a problem. Other times you may have to compare them. So for the amount of increase here, you would take the new value and subtract it with the original value. For your decrease, you would actually take the original value first and subtract it with the new value. And that's just to keep the value positive. But you're basically just comparing the old and the new to see how it has changed. So the percent of increase equals the amount of increase over the original amount. So here, look at the problem. We've gone from 34 to 45. So the change there is 45 minus 34. So we've changed by 11 applications in 1 week. It's gone up. The original amount of applications is 34 here, right? It's going from 34 to 45, right? That from is our starting point. So the original amount is 34. So I'm going to actually look at 11 divided by 34 here. And again, I'm just going to go ahead and use my calculator in this case because it does want us to round. So I get about 0.3235294. Now the second step here, remember when we're looking for a percent, we do have to change it back to a percent. So we're going to multiply this by 100. So I have 32.35294%. And it did say to round to the nearest whole percent. So whole means the ones place. Now the 3 is small, so this is going to stay. So it's about 32%. Let's do one more example there. So a company recently had to downsize, and I think this was a common occurrence for many companies with the pandemic, unfortunately. So a company recently had to downsize. It started with 500 employees and reduced this to 350 employees. What is the percent of decrease? And again, you can go back to the original formula if you want to, or we have those other formulas that just kind of save us a little bit of solving. So it's the amount of decrease, again, which is change. So it's not the final answer, it's the change over the original amount. So here, how is this changed? Well, we've gone from 500 employees to 350 employees. So that's a change of 150 employees. Now, what is the original amount here? So again, you want to be careful. We started with 500. So this is your original amount. So it's going to be over 500. I'm just going to actually divide up that 10 at the end there. So I have 15 over 50. I can also simplify this by dividing by 5 over 5. So I get 3 over 10. Now we do have to convert this to a percent at the end. So we're going to multiply it by 100. So I have 300 over 10, which is 30. So the number of employees decreased by 30%. And again, these percent increase and decrease problems can really get much more complicated too. So we've looked at two styles here, which tend to be two of the more common ones. So again, for the first case we looked at, just as a reminder, we were able to start by knowing the base. Sorry, we're start by knowing the percent and the base so that we could find the amount. So this is a pretty common thing that we do, but we didn't actually talk about what to do if you are looking for the base. So in that case, if it's a simple problem, you can use the same setup as the original here and just solve for the base there. But if it gets a little bit more complicated and you don't know the change amount, then it can get a bit tougher. So it's just something to keep in mind here as you're going through some of these examples.